Hi everyone. So today we're going to be talking about two different kinds of lines. I know we've been talking a ton about lines and slopes and it's driving you crazy, but today we're going to talk about lines that actually you're going to use and see throughout your whole life. And these lines are called parallel and perpendicular lines. Like if you look up right now from your video and you look around your room, you actually see parallel and perpendicular lines all over. From the walls to the windows to actually your computer screen. Any rectangle you see is going to have parallel and perpendicular lines. And parallel lines are lines we say in the same plane. That means that they're just on a flat surface that never intersect. Never. Parallel lines can be drawn like this. Parallel lines can be drawn like this. They can be drawn up and down, straight like this. And those are parallel lines. They're never going to intersect. So if they never intersect, then that would have to tell us something about their slopes. Because, I can have a line that looks like that and a line that looks like that. And eventually, this one I'm drawing is going to intersect it. So parallel lines have the exact same slope. The same slope. If they don't have the same slope, then the lines are going to intersect, okay? So parallel lines have the same slope. All right, so that can allow us to determine whether graphs of lines are parallel lines. So how can we determine whether the graphs of y equals negative 3x plus 4 and 6x plus 2y equals negative 10 are parallel lines? Well, all you have to do is compare their slopes. If they're the same, then they're parallel. If they're not the same, then they're not parallel. The problem is, these are in two different forms. Okay, let's look at the first one. That's in slope-intercept form. Okay, so slope-intercept form. We know that that means y equals mx plus b. We know that m is the slope. And 0b is the y-intercept. Okay, so I see this one. The m, what's in the location of the m is negative 3. So I know the slope of this line is negative 3. All right, my second equation, however, is not in slope-intercept form. It is in standard form. Standard form. It's an equivalent equation of a line. It's just in standard form. So remember that if it's in the form ax plus by equals c, we can find the slope by doing negative a. So m is equal to negative a over b. So in this case, my a is 6, my b is 2, so I'm going to do negative 6 over 2, which gives me a slope of negative 3. Okay, I compare them. They are the same, so the lines are parallel. So we can say the lines are parallel because they have the same slope. Because they have the same slope. All right, let's look at something else, okay? You try it, okay? I want you to try it. Determine whether or not the following lines are parallel. So pause the video and try it. All right, so you're back, and I'm hoping you saw that this first one is in y equals mx plus b, and so our m would be 3, right there, okay? mx, okay? I'm hoping you recognize the second one was in standard form, so you can do a by doing negative a over b, okay? So you did negative 15 over 5, which gave me, so it was negative 15, sorry, negative 15, because there's a negative there, I barely saw it, which is going to give me 15 over 5, which is going to give me 3, okay? So the slopes are the same, so the lines are parallel. So you're going to want to make that statement. The lines are parallel because they have the same slope. Say that out loud to yourself too. The lines are parallel because they have the same slope. All right, let's put this all together. This question says, write an equation of a line parallel to y equals 2x plus 5 and passes through the point 0, 6. All right, well, I see a 0 in this point, so I want to say to myself, okay, my x is 0, my y is 6. So this point is a very special point, the y-intercept. Remember, the y-intercept is where x is equal to 0. All right, well, I want to write an equation with a y-intercept. Okay, a y-intercept of 6. So I'm going to use slope-intercept form. So I can plug that 6 in for b. I just need m. Well, if it's parallel to this line, I can actually borrow the slope. I'm going to borrow this guy's slope. Well, the slope of this line is 2, and if they're parallel, they're the same, so I'm going to borrow a 2. So in this equation, then, I'd get 2x plus 6. So we just wrote an equation of a line that passes through the point 0, 6, and has a slope of 2. All right, let's move on. Now we're going to talk about perpendicular lines. We've talked about those lines before, but perpendicular lines are lines that meet at right angles. Look at your door, okay? Your door has a line going like this and a line going like this. They are perpendicular because they meet at right angles. They create right angles. If I drew a rectangle, which we've been doing all year, we know that it has 4 right angles. So this line and this line are perpendicular to each other, or those segments. But another way to say that lines are perpendicular is to say that their slopes are opposite reciprocals. Now we've talked about the word reciprocal. Reciprocal means kind of the flip of the number. So if I tell you like 1/2, the reciprocal would be 2 over 1. Opposite just means the opposite sign. We've talked about that word a lot this year. So if lines are perpendicular, they're said to have opposite reciprocal slopes. All right, well, let's look what that means. So if a line has a slope, or m is 2, a line perpendicular to it, first put it over 1, is going to be -1/2. We flip it, we change the sign. Okay, a line that has a slope of 1/3, well, then a line perpendicular to it has a slope of -3. We flip it and take the opposite sign. All right, a line has a slope of -2/5. A line perpendicular to it has a slope of 5/2. All right, so how can we use this? Well, it says tell whether or not the graphs of y equals 3x plus 1 and 2x plus 6y equals 6 are perpendicular lines. We're going to do exactly what we did with parallel lines. We are going to compare the slopes. We're going to compare the slopes. All right, so if we compare the slopes, I see that this is slope-intercept form. It's in the form y equals mx plus b, and my slope is 3. All right, this one is in standard form, ax plus by equals c. To find the slope, we're going to do that the m is -a over b. All right, so that gives me -2 over 6. I'm going to simplify that to -1/3. Now I'm going to compare the slope. Are they opposite reciprocals? Well, if you look carefully, yes, they are. So the lines are perpendicular. Okay, so for parallel lines, we compare the slopes. If the slopes are the same, the lines are parallel. If they're perpendicular, then it's opposite reciprocal slopes. All right, but what the heck do we do with our special lines? Remember, the special lines are horizontal lines and vertical lines. Well, we know that the horizontal lines have a slope of 0. And we know their equations are always going to be y equals a number. Vertical lines have undefined slopes. And their equations are always going to be, x equals a number. Well, what we need to make sure we understand is that a horizontal and a vertical line, they actually meet at right angles. The problem is that their slopes aren't opposite reciprocals. So this is a very special case. I mean, they are opposite reciprocals, but you just can't see it. So if a slope is undefined, that means you have a vertical line. You have to remember that a horizontal line would be perpendicular to it. And just think about rectangles or even your door again. Look, this is a vertical line right here, vertical, and this line right here is horizontal, and they are perpendicular to each other, okay? All right, so let's use that and let's ask ourselves some questions, okay? What's the difference between the slope of a line and the equation of a line? Well, we've got to remember that the slope is a ratio, which means a fraction of the change in y over the change in x of any points on the line. An equation of a line is the equation that represents every point on the line. And we have three different equations of lines that we know. We've got slope-intercept, we've got point slope, and we have standard form. All right, so if parallel lines have the same slope, what is a horizontal line parallel to? Well, it would be parallel to another horizontal line because horizontal lines have the same slope and they both are 0. All right, last question of the day. If perpendicular lines meet at right angles, what does that tell me about a horizontal and vertical line? Well, it tells me that they are perpendicular. All right, guys, hopefully that was a helpful video. Tomorrow we're going to be comparing lots of slopes. Have a great day.